Good afternoon. Today we are going to see about hydroelectric power plant models. In the last class, we have seen about the characteristics of thermal, that is steam power generating units. So input-output characteristics we have seen. Input-output characteristics we have seen. Then the hydro pumped hydro power station, that concept. So based on that, the characteristics also we have seen. So now we are going to see about hydroelectric power plant models. Okay, already this hydroelectric power plant model already you have studied in your power system subject itself. So if you see, like, this is the like a structure of hydro power plant. So wherein which there is the dam where the reservoir or dam where the water is being stored. So, and in the dam, you'll be finding this track racks and intakes. So track racks, what is the main use of this trash racks is in the sense. So if, example, this dam is being filled due to heavy rainfall, automatically what they will do is they will open this trash racks. They will simply open this trash racks so that the excess water from the dam will be just moving to this downward side. In recently, what happened is in China, due to the heavy rain, what they did is they busted this trash rack itself. Why? Because if you are stored more than the capacity, say for example, your storage capacity of dam is maximum storage capacity of your dam is 120 feet, but you should not store the water to extent up to 120 feet. So what you have to do is you have to store only up to 100 feet. So like if you store 120 feet, what will happen in the sense, simply like that, it will damage this structure also, this whole structure. Then constructing of this whole structure is not at all an easy task. Okay, so you know the constructing of dam, it will takes 5 years, more than that, 8 years, 10 years, like that. Once if you plan now, for example, if you are planning for a new dam now, 2021, I think you have to wait for another 5 years, that is 2026. Then only you can store the water like that. So if the dam is placed if the dam is constructed near to the like mountain valleys, so like that the nature itself will be acting as a dam structure. Because if you take like two valleys, in between the two valleys you can easily store the water. That is called the catchment area. Okay, so that catchment area you'll be finding. So in that catchment area, water will be easily stored. So you no need to construct the dam if you are in the hilly regions. So if you want to construct a dam in the plains region, then the problem comes. So what you have to do is you have to dig like 120 feet, 150 feet, like that depth you have to dig for this many acres. You have to dig. Then you have to frame the dam for this many acres or kilometers, 10 kilometers, 20 kilometers. You have to you have to do all the things that will take much more time. It is not an easy task. So that's why the nature itself in such scenario, the nature itself acting as a dam, and you can easily store the water over here. So this is the reservoir. So inside that, this is also, you'll be finding this type of structure in the dam. So inside that you will be having your penstock. Okay, so penstock is nothing but a pipe. A pipe means a big pipe. So here the valve valve house will be there. Then a surge tank will be there. That is suppressed in this figure. But I think you already studied what is the use of valve house. So valve house, as I already said, based on the amount of power generation in the particular generator. Say you want for 100 megawatt, say you want 200 megawatt. Based on that, in the valve house, what they will do is they will open the valve fully, or they will partially open. 3 by 4 will be open. Like that depends on the and how much pressure you want, how much like velocity you uh, um, want for hitting that particular turbine. As I already said, that the pressure that is generated within that penstock, that water, okay, it will be having like around 120 kilometer per hour to maximum of 150 kilometer per hour. So 150 kilometer per hour is maximum speed of a train. So that much pressure is hitting a turbine. So this turbine will not rotate in a like 1500 rpm, what you are seeing in your like a laboratory, in your machine's lab, or the machine's lab you already did know. In that you'll be finding an alternator which is rotating within with 1500 rpm, because it is being coupled with the motor. So motor rpm is 1500 rpm. So meanwhile, same generator also rotating in 1500 rpm. Whereas in this scenario, your speed of the turbine will be of only 200 rpm. 200, it will be rotating in very slowly only. But the thing is that poles will be having 6 poles, 8 poles, like that. It depends on the generators that already you studied in the machines, the poles, like designing of the poles. And so here, if you see that this penstock only, the water will be flowing via this penstock. So whereas that is hitting the turbine, this is the turbine. So this turbine will rotate it is being coupled with a generator. So after that, the waste water will be there. That waste water will flow through this draft tube. This draft tube only will be going to the next stage of the dam. And also in this next stage also, you will be finding the crosshead of the dam. So here one more surge tank will be there. Surge tank. So what is the use of this surge tank? Surge tank in the sense, the pressure in the penstock. So as I said, like a huge pressure will be there in the penstock. So if it is, say for example, you will be closing the valve. You will be closing the valve simply when it is not used. In that scenario, the water will be flowing up to this up to this penstock, and this penstock will have more and more pressure. So that might be having the possibilities of busting the penstock. Sometimes what it will happen is simply it will damage, it will destroy or bust. In that scenario, so it is this penstock, sometimes it will be placed inside the mountain regions, like that. So the penstock length will be of 1 kilometer, 1.5 kilometer, like that. Okay, so in the deep forest, inside the mountains, this penstock being inserted, not only you will be finding one series of penstock, you will be having some 5 to 10 penstock, because if once the penstock get failure, means easily you can switch over to the next penstock and next machine. And also, if you see in the hydropower station, you will be not finding only one generator. So you'll be finding the series of generators. So 100 megawatt generators means 100 megawatt into 5, or 200 megawatt generator means 200 into 5, like that. 5 to 10 generators will be there. So based on the demand, say for example, today's demand, with that demand, you ask to generate 1000 megawatt. So that what they will do is they will on a 200 megawatt generator of into 5. That is 200 into 5. 200 megawatt generator they will choose for their generation, or otherwise 100 megawatt into 2, then another 200 megawatt into 3, like that. Based on the demand, they will on that particular generator. So you will be finding the series of penstock inside. So anything happens, any damage happens in the penstock, so simply it will damage. And also constructing again this penstock will take much time. It will take a week because it will be placed inside the mountains or inside the ground surface. So you have to dig a pit, and you have to take the Penstock out, and you have to replace. Maintenance is very difficult task. So by that case, what they will do is they will simply install install one surge tank over here. So what surge tank will do is, so pressure inside the Penstock, say for example, water is flowing like this in this direction. So automatically pressure will be increasing. Now automatically in this one tank will be there here. So it is also connected to this Penstock. So automatically water level in the tank will get rise. So automatically pressure inside the Penstock will be decreasing. So that it can safeguard your turbine also. Turbine also will be safeguarded. Why? Because turbine you can't simply replace once in a while like that. So monthly once, or 2 months once only they will go for a maintenance. Okay. Turbine, taking the turbine out again, we have to maintain again. You have to fit inside. It is not an easy task. And also, if you find the like a hydropower plant, so it will be like a top portion will be somewhat open. Like it will be they will be putting some sheets like that. So why? And also you will be finding a very big gate near to the hydropower plant. So why they kept that very big entrance? Because easily they can carry these machines, the generators, then turbines, shafts, then many mechanical components might be there. So generators, shafts, they want to replace now easily. One crane also will be there. So easily they will take that generator, and wherever they want, they can easily place. And also, like if you see the country like India, so now almost if you find if you take any hydropower plant, it is of like 80 years old up to 100 years old. It is of like 80 years old, 100 years old. Still the turbine ABB machines are still it is running. Okay. Still this old machines, even that ABB company is not having that components. Even still in India, we are running that generators. So why? Because we are maintaining, and we are developing nation, and still okay. So we are going for operational maintenance once in a while, and still we are replacing certain parts, and we are running the turbine. So Indian hydro turbines are still 60 and 70 years old, 80 years old. Still it is running. If you go to any of the like hydropower plants, so until otherwise, if they constructed newly, you will be finding new generators, or otherwise most of the generators, 90% of generators, you will be finding very old generators only. ABB generators, very old generators. So previously what it was happened is still, if you want to replace a shaft, or if you want to replace any of the windings, so you need to transfer, you need to purchase from their own country, that is Italy or Germany. They only will be providing the this particular shaft, with particular nuts, bolts. Even nut bolts also you will not find out, because they will be having the copyright then that patented. They will be not providing. You will not get in the local market. So you need to go for that particular country. German country means Germany. You need to ask for a quotation. Then it has to come to India, and again you have to install that. So that is a very difficult task. Okay, so like that, so very old generators also there, and also maintenance of turbine. Turbine also always it is there in the water. So like once in a while, that is monthly once, you have to go for a like frequent maintenance, and via this draft tube only, this water, that excess water after heating the turbine will go out. So again, if the same thing, pumped hydro storage plant, if the same power plant is acting as a pumped hydro storage plant, in the sense, what they will do is they will simply again pump the water via same draft tube. So this generator will be acting as a motoring action. Okay, so if it is rotates in the opposite direction, the same generator will be acting as a motor. So in that scenario, the water will be get pumped again via this Penstock, and again it will flow to this reservoir, that is dam. Again you can store, but that too I said one condition. Why? Because non-peak hours only you have to go for. Peak hours, if you go now, again I said 60 to 70% of the power is being generated here in this generator is used for same power is used for pumping the water also. So that is even we are generating, again pumping the water means that is of no use. So only with the non-peak hours only this operation will be done. And if you see, like only few generators in India is of pumped storage plant. Why? Because once the water is being discharged, in many of the states, what they are doing is they are utilizing the same water for the irrigation purpose also. So based on the how much TMCs of water we are having in the dam, so what they will forecast like some TMCs of water, they may take that to for irrigation purpose also, and some for another stage. So say for example, this is the first stage. First stage you are generating together you are generating 750 megawatt. The second stage, so some water will be utilized for the irrigation purpose. So some water, what we are doing is we are taking that water is flowed to next stage of the dam. So next stage again we are having some 100 into 500 megawatt generators. There again we are generating 500 megawatt. So again it is flowing to some other kilometers, some 30 to 30 kilometers, 20 to 30 kilometers. So again we are generating, because we are maximum utilizing the water resources. Because if we are in southern India, so definitely we have to rely on our rainfall only. So whereas in northern India, some many rivers, ever flowing rivers are there. So in a year you will get more than 350 days you will be getting the water in the northern regions. Whereas in southern India only we are forecasting based on the rain only. Once if it rains heavily, then we'll go for full generation with the hydro itself. If it is not raining, means again we have to rely on some thermal base loads, like thermal generating units. Then some other renewable energy resources we have to rely on, wind sources like that. So that is also one of the concern we have to think. So this is the working of the pumped hydro storage plant. So that is what it is being explained once you study this. So what are the turbines used? Okay, Francis turbine, Kaplan turbines. So up to what feet, what ranges? Low range means okay. So this Francis turbine. Then like high range, that is 60 feet. So and if you see most of the parts of southern India is low head hydropower plant. As I said, all dams are depend on the rain, and also from the river, water from the river. So that we are relying on that river water and as well as the rain. So once if the water will be coming from the river, then we are storing into the dam, and after sometimes we are utilizing, or otherwise we are expecting the river. So like that, based on that, like medium hits within the range from 60 to 1,000 feet. 1,000 feet now. This ranges of like foreign countries. In India, we are not going for this range. 60 to 1,000 feet. 1,000 feet and all, and no dams is there. Okay, so up to like 150. 200 like that only our dam size is there. And the Francis turbine. So the Francis turbine, and if you take like low heads like 10 to 60 feet. I think this is foreign author book, no? So that's why they have given like this. The exact thing I'll show you, like the Kaplan turbine and all. So next we'll move on to this characteristics. Yeah, this is the incremental water rate characteristics versus the output power. So if you see like the units, the many units, as I said, so this unit number one is 100 megawatt, this is 200 megawatt, this is 500 megawatt, this is again 200 megawatt. So there are like four generating units. So here what we are taking is incremental water rate, that is Q, discharge Q. So Q, what is the unit of Q here is acre feet per megawatt hour. So acre feet per megawatt hour. This is the unit incremental water rate characteristics. So based on the head, based on the net head of the dam. So the say for example, the first head is 110 feet, another head is 150 feet, another head is 100 feet, another head is 75 feet. Like that, based on that, the power generation, and also based on the discharge of the water. So based on the head, you will get the discharge also there. So if you see the like this graph, this curve, it is gradually. So initially it will be somewhat up to say for the 10 to 25 megawatt. That is around 15 megawatt. It is gradually it is increasing. Again, it is increasing like anything. Again, it is increasing, and it is going to based on the discharge. It is like increasing. So here also, second unit also. Here it is increasing at a constant level. After that, it is maintaining. Okay, so based on the demand sometimes demand will be of more, sometimes demand will be of less. And also I said no in that valve house. So valve house, they will be closing fully opening the valves, or sometimes they are partially opening. Sometimes 3/4 they will be opening. So based on that, power generation also will be happening. But nowadays, due to the summer season, there will be full flow. They will be opening fully. But even though you have to you have to go for the water level also. Water simply like that. If you utilize all the water for simply generating the power, then what happens to our agriculture? Then the future forecast also you have to get. So that's why monthly, what they are doing is they are going for short-term forecast and as well as the long-term forecast. So short-term forecast, what they will do is they will do for from 1 day to 1 week. So 1 week, what will be the water level, and what will be the expected water level from the river to dam. Then what will be the feed for 1 week. Then from that this much cubic like meter, not cubic meter, this much TMCs of water, how much like power we can generate for 1 week. So like long-term forecasting, in the sense from 1 week to 1 month, or 1 month to 1 year, 1 month to 1 year. So 1 year, 365 days, 365 days. So what is the water average water level, and how much power is being generated? So that whole report, what they'll do is that like your public works department only will be collecting all this data and will be giving that to your electricity board. So thereby your government of say here government of Telangana will be approving. So based on this this water level, you can generate this much of power. And if say now summer seasons, daily we are getting half an hour to 1 hour power deficit is there. Or daily in your home also you will be getting half an hour to 1 hour power shutdown will be there, because the demand, we can't able to manage the demand because we are forecasting something, but in the practical it will be more than that. We are say for example 13,500 megawatt we are forecasting today, but the actual scenario, if you combining all the loads in Telangana, if you take like it is 13,600 or 700 megawatts. So 200 megawatt is deficit today. So 200 megawatt deficit, how to manage? Like in every area, they will cut the power for like half an hour, 15 minutes, 20 minutes, like that. They will touch the remote areas and they will simply manage that power deficit also. So that is also there in this. So this is the incremental water heat rate characteristics. So next, yeah, I think this all you studied. So I'm skipping this fully. Why? Because this all you studied in power system 1 itself. Yeah. Yes. Next topic is scheduling problem. So scheduling problem, types of scheduling problem. As I already said, there are two types of scheduling. So one is like hydro scheduling, then thermal scheduling, and also in that particularly short-term scheduling, long-term scheduling also there. So in the class we have seen the only thermal power plant schedule. We have solved many problems also. Then hydro scheduling we are seeing now. So like combiningly hydrothermal scheduling, like two generating stations. So here what we are doing is yeah. So two unit hydrothermal schedule. So hydro and as well as steam, that is thermal, is being combined, and two units we are scheduling. So if we simply rely on hydro itself, you can't able to satisfy the demand. Sometimes your water flow will be, so water level will be dropping. In that scenario, you have to go for some other generating system also. But these two are the base. These two are the base. In like very peak time, they might be going for steam for generating units. And sometimes in like a water flow is good, then then in that scenario they are touching this hydro station. So now we are going to see we are going to see some introduction about the hydrothermal schedule. So here the hydro and as well as thermal together is with satisfying the load, that is demand, together satisfying the demand. So imagine if one system is not there. Imagine only one with the steam only we are generating the power and we are utilizing the demand. In that scenario, what happens is the cost will be goes like anything. So 24 hours, if you are generating 13,000 megawatt with the whole 24 hours with only steam, means it will comes like crores and crores of rupees. Then it will reflect on our tariff only. So now we are paying around 5 to 6 rupees for single phase supply, and 3 phase around 6 to 8 rupees we are paying for 3 phase. So it depends on the seasons. Winters seasons they are charging something, and summers they are charging more. And in some states they are charging the base tariff, some base tariff, one charge for all the seasons. Like that also they are charging. So imagine 6 rupees you are paying. If the whole generation is happening only with steam generation itself, so how much rupees? Instead of 5 rupees, you have to pay around 20 rupees. So like 3-4 times the tariff will be increasing for you. Again, so imagine if you are not using only steam, only you are relying on hydro alone for generating. So hydro alone, no that much installed capacity is there. First of all, you can't able to generate 13,000 megawatt only with hydro. So only installed capacity is of very low. So imagine the whole thing you are generating with hydro alone. So hydro alone. So the level of the dam, the water content also one of the constraints in which if you are generating with the hydro. So that constraints also you have to take it into account. So if you are going to generate all the power with even hydro itself, so your all the water in the dam will be get wasted up. So no single drop of water will be there in the dam. So in that scenario also it will be very tedious to tackle this demand. So that's why we are going for hydrothermal schedule. And also you can add here wind also, here some other renewable PV, solar PV also, then some other gas turbine units also, like many things you are adding here. Then the complexity of the problem will get very, very high. So it is not a very easy problem to solve if you add many like hydro, steam, then wind, then solar PV like that. So simply whatever we have seen as of now, like only steam generating units is satisfying the demand. So this part alone only we have solved the problem. So imagine this also will be comes into the account. So here also different fuel cost, and here also different constraints. So if you join together, so you have to tell from which unit in a 24 hours. So based on the demand, so in which hours you have to touch the optimally you have to utilize the generating units. That is the economic load dispatch, no? So optimally, so which say for example peak hours you have to go for steam generating units. Again, non-peak hours sometimes you have to go for hydro units. Sometimes peak hours you have to utilize your wind. Peak hours you have to utilize your solar PV. Like that, you have to distribute. Then if you combine all these things, then the complexity of the problem will get increased. Okay, that also there in this hydro power station.